Hello everyone, welcome back to the channel. I hope you guys are doing really well. So let's see today's daily challenge on LeetCode and we will try to solve it together. So today's challenge is not a very difficult one, but if you do not think it in the correct direction, there is a possibility that you might get messed up. So yeah, let's try to understand the problem statement. Maximum frequency of an element after performing operations. So you are given an integer array nums and two integers k and num operations. You must perform an operation num operation number of times on num. So this is the constraint. This is the maximum number of operations you can perform. And how can you perform the operations? In each operation you can select an index I that was not selected, and you can add an integer in the range minus k to nums I. Okay, so basically for each of the numbers you are allowed to add minus k to k. So you can treat each number as an interval, and basically you want to find that how many what is the maximum possible frequency of any element in the nums after performing the operation. So after performing all of these nums operations, what is the maximum frequency of elements that you can get. Okay, so that's what you need to do. Okay, so definitely you can have various kinds of brute force approach for solving this, and I hope those things are trivial and you will be able to figure that out. To think this in the correct direction, what you need to do is that let's say you are having a number array, right? So in this array you see you have some elements. What you think is that uh, why not try to see that what is the maximum possible frequency of this particular element. Okay, so it means that it essentially means that I am trying to convert as many elements into this. Okay, so you will say how will that work. Okay, so let's say there is some in between element. I will check this for all the elements and take the maximum value. Okay, let's say I want to convert all the elements into this particular element. Okay, so pardon me, I do not have my pen with me, graphics tablet pen with me. I am doing it with the mouse only. So yeah, let's say I want to convert this number. I want every number to convert into this. Okay, so I want to see that what can be the maximum possible frequency. Now you see this number actually acts as a range. Why? Because this number, let's say this array is a and this number is nothing but a of I. Okay, now this number is nothing but a of I, right? Now this a of I is not just a number, it is something like starts from a of I minus k to a of I plus k, right? Because you see, if you try to convert all of the numbers within any number of this lying in this range, a of I plus k to a of I minus k, you will be able to get that many frequencies, right? So you check for three boundary points. What are those things? Is that a of I minus k, a of I and a of I plus k. So what did I say just now is that uh, first of all you will try to convert all the elements. You will try to see how many of the elements can be converted into ai, how many of the elements can be converted into ai minus k, how many of the elements can be converted to ai plus k. So what I am trying to say essentially is that let's do through the coding part only. So let's say you have a number n and you want to convert, right? What do you want to convert is that you want to convert every element. uh, you want to see, like if I convert try to convert all the elements into a number n. Okay, so for number nums I, okay, for number nums I plus k, okay, for number nums I minus k, I want I want to see that how many elements can be converted into this. Okay, so let's say I will have some function convert, okay, and have an answer also. See, I want to maximize my answer, so every time I will take the maximum value. So I will have a function convert. Okay, so this is what I will try to have. Okay, so n plus k and minus k, and I will definitely have one answer, global variable answer equals to 0, right. So what do I want to do is that I will try to write a function nums I, let's say it will take this nums also, and definitely it will take the value k, okay. It will definitely take the value k, and yeah, the number of operations also is what it should take. So let's say I will just have another variable, or let's say number of operation, I will just change the name of this to m, okay. This is the number of operations. I do not want such a big name, that's why I just write this. So do you understand what this convert will do? What I am trying to write another function convert, okay. So what will this do? It will try to convert each and every number into that this nums of I, okay. So let's say I have this vector int nums, int k, and definitely int m, and definitely I have an n, okay. So basically what this function will do is that try to see how many numbers can be converted to n by using m operations, okay. By using m operations, how many numbers can be converted into n, okay. So that's what I will try to do, and I will just try to return answer, okay. Let's see how can this work exactly. So you see, what you can do here is that you can try to use upper bound and lower bounds, okay. So let's try to sort it, okay. I hope you don't need an intuition of why exactly I am sorting, because it's quite obvious. Yeah, so I want to select numbers in the range of minus k to k. Sorting won't affect my answer definitely, okay. So yeah, definitely then I can sort. So yeah, I have it. So what I can try to do is that see how many elements can be converted to n, okay. Now how can I see that without using a loop? See, I am using a loop here also and calling a function. If I try to use a loop here, it will be n square solution, and n square won't be accepted, right. So without using a loop, I need to find how many numbers can be converted to n, and given the array is sorted, okay. The array is completely sorted. So how many numbers can be converted to n, okay. So let's say you have some things. Let's say you have a number a1, you have a number a2, and so on. In between you are having a number n. Let's say you have 3 times, okay. There may be repetitions anyways, and they are in the increasing order definitely, since I have sorted it, okay. And let's say you have more numbers, let's say a23 or something like that, all the way till an, okay, or ax, whatever be the case, whatever value you take, a capital N, okay. So let's say this is our number, and I want to see how many numbers can be converted into n. So you see, the existing numbers which are n, they don't need anything, right. They don't need any number of operations. I do not need to use any operation m in order to convert the number which are already there, right. So they are already there. So one thing I can do to count these numbers is to use both the lower bound and upper bound on this n, okay. So what I am trying to do is that let's say find the index L, okay. What will be this index L? It will be nothing but lower bound. What does lower bound? I hope you know already, right? What does lower bound and upper bound gives in C++? If you are using some other programming language, you can use a binary search, but it simply uses a binary search. But lower bounds give an element which gives the first element which is greater than or equal to the argument which you pass here, and upper bound gives the index or the iterator which is just greater than the number which you are passing. So let's say after n, let's say there is something like n plus 4, so it will give an index which is pointing to n plus 4, okay. So yeah, and it goes without saying that the array is definitely sorted. So what you pass through this nums dot begin, nums dot end, and you pass this n, right? So you want to find what is the lower bound of this end, and also the right one you can get easily by writing the same thing with upper bound. So you have it, and you see how many, if I try to tell you that how many n's are already present, which we can, so while returning, right, while returning this many number I will definitely get. And since this is an iterator, right, it returns an iterator, lower bound or upper bound. So that's why I will in order to get the index, I will try to subtract this nums dot begin. Okay, okay. So this is the number of numbers L R R minus L. So this will give me how many numbers are already n. Okay, so this R minus L is nothing but so what I am trying to do, I will do I will try to return how many numbers are already n. Okay, how many numbers are already n plus how many numbers can be converted to n, can be converted to n. Okay, so how I have already got how many numbers are already n, which is nothing but R minus L. Okay, and how many numbers can be converted to L, that is the question right now. Okay, so definitely how many within the value of n minus k and n plus k, they can be converted to n. So I hope that is also very simple. I will use the lower bound again, I will use the same thing, but instead of that, instead of n, I will use n minus k, and let's say I will try to write this again, and I will use an upper bound definitely, and instead of n minus k n, just I will use n plus k. So how will this affect? I hope you do understand, right? If I try to write this on the number line of LL and R exactly, you will get something, right? What will you get? Let's see, let's try to write this on the number line. So you have some numbers, and then you get LL, right? Then you have some numbers, then you will get L, then you have some numbers, then you will get R, then you have some numbers, then you will get RR, and then you have all the numbers. Do you realize that you will get something definitely in this order? And L to R is nothing but all these numbers have the same n in between. So in between there is nothing but n things are there. Okay, and here LL is the border of n minus k, and RR is nothing but the border of n plus k. Okay, now I want to tell you that see, R minus L is the number of numbers which are already, I mean which are already n, you don't need to convert them. Now if I tell you how many numbers can be converted, definitely you will say L minus LL and RR minus R. I hope that is not at all difficult to understand, right? So you can have a result which you can write is something like L minus LL. So these many numbers are lying in the range of n minus k to n, and they can be converted to n, and these many numbers can also be converted to n. So RR minus R. Okay, you can definitely do that, and you see now you are constrained by this operations m. Okay, you are definitely constrained by this number of operations m. You cannot do anything which can hamper your number of operations. So what can you do? You can definitely use a minimum function, because yeah, if you see these results, this many numbers, each conversion to n takes I mean each conversion to n takes one operation, right? So if this value exceeds m, you cannot really use that. Okay, and you can take minimum of m comma result. Okay, and these many numbers which are already n, they do not use any operations, so you do not include them in your minimum function, right? So this is what you can return simply. Okay, and I hope you do understand. I hope this was not difficult at all. If you think it in the correct approach, this problem will not be difficult at all. So you can just try to submit this and check if it works. So let's do some debugging. Let's try to make it work. We got the accepted for this. Let's try to submit it and check if it really works for all the test cases. So yeah, cannot be represented in type end. Okay, so let's try to convert everything to long. Yeah, so yeah, so we will try to convert this has defined everything to long. Okay, so yes, basically this n plus k they are unable to have in the long format, unable to have in the integer format. Okay, so why not have this only long and try to check if it works. So I will use this test case and try to make it work. Will it still give me an error? So these are anyways giving me indices, right? Even if I was thinking that even if I make them long, there won't be any effect of that. And uh, unexpected unqualified ID. This is nothing but is it giving me a compile error? Why is that so? Okay, so you see I did hash define ll as long and using the same variable ll right now. Okay, so I will just try not to use this and write this whole long over here. Okay, will it work or it still has some issues? It works for this test case. Let's try to submit. If it doesn't work, then we have to figure something out. Yeah, but it does work, and you see we do have a decent runtime as well as memory complexity. And what is the time complexity of this code? You see it is n log n because you use the log n time complexity for this convert function, and you have this n. If you just try to analyze time complexity, you will get n into log n. It is telling you, but yeah, you do understand that it is definitely not that n into log n, because you see if it would have been that, you see n square only would not work. It will be simply n log n solution. Okay, because this is the loop of n and it uses log n time complexity for this lower bound and upper bound, as it is simply binary search. So time complexity is not n square log n, it is just n log n. Okay, please note that that is given to be an error here. So yeah, I hope the solution was at least very clear to you. If you still have any doubts, you can definitely ask me in the comment section. So yeah, that's all for this video. I will meet you in the next video. Till then, thanks a lot.